Many of you have heard of the photo scanning backdoor that Apple is introducing called Neural Hash. This basically will spy on the images on your phone, and if it discovers any that conform to its list of banned images, then you will be reported to law enforcement. What I'd like to provide today is a deeper understanding of this capability to discover what is in an image, not just on iPhones, but in your environment. Image scanning technology is already used by YouTube to examine video footage frame by frame using an AI. They use it to see if uploaded videos conform to their terms of service. In other words, they use it for content moderation. The scanning of images to determine its content using AI is used extensively on Google Photos, iCloud, Ring, and shortly, as announced, it will be on iOS devices. Would you like to learn more? Then stay right there. I have a VPN service, Bytes VPN. My company also sells Google phones and VPN routers. If you're interested in them, they're on my app BraxMe, and the link is in the description. After my last video about Apple's Neural Hash, YouTube alerted me that that video was demonetized. Now that's pretty interesting because the AI scanning images was actually the subject matter of that video, and YouTube did that scan to demonetize it. In this video, I will once again focus on image scanning, but I will not reference why Apple is supposedly implementing this Neural Hash image scanning backdoor on your iPhones. You'll just have to figure that out yourself. Thank YouTube for that. But I'm going to present this information with a different twist. Hopefully the visuals I will show will give you a deeper understanding of this very powerful technology. I'm going to discuss this image scanning technology as made up of two parts. The first part is image recognition. The AI recognizing the individual elements of an image and establishing a context. The image can be direct from the camera or on a saved photo. The second part of this technology that I will talk about is how an Apple can send instructions to the slave device to look for a target, any target. First, let's talk about image recognition. Image recognition has been available on many consumer devices for a long time. For example, I'm doing this video on a Sony a6400 camera. This camera has an autofocus AI. That means that it autofocuses by following my face on the screen. Or in some cases, it will follow my eyes. You can see how quickly it can change focus. Now watch this. So, rather than just looking at an image just as a static collection of light and dark spots, an AI looks at the image in real time and looks for some context that can be used by the device. In the case of this camera, it will look for something that looks like the closest face. Then, finding that context, the camera then adjusts the lenses to bring the desired part of the image into focus based on where that image object is positioned on the screen. The camera does this in real time. This is not done after processing a photo. That's something important to remember because often I have referred to this technology as photo recognition. But I'm rephrasing this to image recognition since it could occur with a camera in real time before an image is even stored. So just keep that thought in the back of your head. In order to understand advanced technology relating to image recognition, I will demonstrate a product to you called Amazon Rekognition. Amazon Rekognition is actually a cloud service that Amazon offers. Anyone can quickly write a program that can integrate object and facial recognition into any application. For example, Amazon Rekognition is now used to scan people at airports since it is the technology adopted by ICE, the U.S. Immigration and Customs Enforcement. Mostly they use it for facial recognition. But as you will learn, this technology is only partially about facial recognition. Its strength is actually in understanding the context of what it sees through the lens. And that will be our starting focus. Amazon Rekognition is of course an Amazon product, but this type of technology is used by Facebook, Google, and now Apple. So whatever I explain relating to Amazon will be similar to capability that is available to all these other big tech companies. The first capability of Amazon Rekognition is called label detection. What this means is that the AI is able to spot learned objects and then gives those a label. Now, this example here is very simplistic. It's showing an ability to recognize general objects like vehicles, skateboards, people. But this is customizable. Basically, an AI can be taught to recognize anything, specific car models, specific racial profiles, specific brands or products. The second example is able to analyze a city view based on an environmental context. A more advanced implementation of this would be to actually identify the city by name and region. Just so you take this a step further, an AI can actually recognize what part of the world you live in based on the style of your interior decoration without even looking outside. The general object recognition, though, is used to establish some environmental context. Now let's look at this second example, which is called image moderation. Here, the AI will look for a context which can then be used for moderation, perhaps in social media. The first example is a family photo, and here the AI does not flag anything based on its instructions. But in the second example, the AI identifies a context that it can determine as a possible trigger. Look at the way the AI recognizes suggestive behavior or revealing clothes. Understanding the context is a very human kind of response, so the machines are being taught to recognize things like a human. In this next level of AI recognition called facial analysis, look at the progression of the AI. It is able to integrate more context, gender recognition, age range, smiling, appears to be happy. At the same time, it is able to recognize specific objects like the fact that the woman is wearing sunglasses. In this example of facial analysis, note that multiple faces will be analyzed separately. The next example is called celebrity recognition. Here it recognizes Jeff Bezos with 100% probability. And then the next example is the new head of Amazon, Andy Jassy. It should be obvious here that any famous or infamous person can be matched. In the movie Jason Bourne, Bourne is frequently spotted on cameras in train stations and is immediately reported to the three-letter agency. My point is that this is not movie fantasy. This technology is here now. This next example shows how multiple faces are analyzed separately and comparisons can be made against another image with multiple faces. Now, this example is used by YouTube a lot. If I put any kind of text on the video, YouTube will be able to transcribe it even if it is not verbalized. And here it is able to track the license plate. You can see this technology used heavily in cities like Los Angeles for plate recognition cameras in roads and freeways. Likely it also uses Amazon Rekognition. Now here's something that is very useful in today's context. The AI is able to identify who's wearing a mask and who is not. It's even able to identify violators per the AI who do not cover their nose. I can just imagine this used as an alarm for everyone walking into a building, something that I'm sure will be coming soon. So what have we learned here so far? The image recognition technology is evolving to a level of AI that's starting to become very human-like. If some intelligence agency were looking for a Jason Bourne, the technology to find a specific person is obviously an existing capability. But this technology is able to go beyond something obvious, like facial recognition. It's able to recognize the context of the image. Also, what may not be apparent is that they're putting this capability eventually on every camera. Big city surveillance cameras are already able to be programmed to do any of this image recognition at will. But now your Ring camera that many of you install in your house will likely now participate in the surveillance infrastructure. In case you forgot, this recognition engine I just showed you is from Amazon, and Ring is owned by Amazon. And if you missed this from my prior videos, every Ring camera feeds a central database with all your videos and made available to law enforcement and intelligence agencies. Now, to round it off, Apple's iPhone will now be included in this. This AI will now be part of the new iOS 15, and so it would be a simple matter of just capturing images seen by the camera even without saving a photo. This can be used to examine the environment for a context that is being searched for, and it can do it in the background. Since the actual image is not being sent to Apple, then they would be able to claim that it preserves privacy. Tesla vehicles and other vehicles doing some sort of self-driving are already equipped with advanced cameras located all around the vehicle. And if you've ridden in a Tesla, you can see some pretty advanced object recognition being done to examine the environment around you, recognizing types of vehicles, signs, traffic lights, pedestrians, bicyclists, dogs, garbage cans, and so on. Versions of this, like in Google's version of self-driving called Waymo, will send these images for central monitoring. But understand the new environment here. It is not necessary anymore to send large amounts of traffic to a company HQ to make observations of an image. All you have to do is to provide an AI for what is needed at the device itself. And the only thing passed back and forth between a camera device and an HQ are the actual observations. Now, how can a security camera send a small amount of data to HQ saying there is a match of a targeted image context and whatever it was tasked to find? If, and this is only an if the AI capability is placed on the device and not on the cloud, then the data sent would be very small. For Amazon, it wouldn't even need an internet to send small amounts of data. A camera could easily use the Amazon Sidewalk Mesh Network, which uses radio transmissions up to half a mile away using Bluetooth Low Energy. So even remotely powered cameras installed in streetlights could easily pass information that Jason Bourne was spotted or some known right-wing individuals are meeting in the park. This can then be forwarded to the internet when the radio message is received by a device that has internet access. And just to make sure you understand the technology, Ring cameras have built-in support for Amazon Sidewalk. You can easily install a bunch of cameras for cheap to cover an area and with no wiring be able to fully surveil with little infrastructure required. However, at the moment, the Amazon Recognition API is in the cloud, so it still sends a lot of network traffic. So this may not be workable yet as I described. Now, this is a bit different when compared to the iPhone. Here, the processing power of an iPhone is at the desktop level. Apple will in fact put the image recognition AI on the phone itself. Thus, it would not be dependent on any cloud infrastructure as it would be when it uses Siri. So this is an image scanning game changer. Tesla's image scanning is also built into the car computer, not centralized at Tesla. So each car interprets its surroundings independently without an internet connection. However, the phone is quite a bit more portable and gets into more private places. The Apple stated intent is that the iPhone will scan your photos for illegal content and only if it's slated for iCloud storage. I'll get back to this very dubious explanation. But let me just say that the technology for scanning an image doesn't have to be on a saved photo. Just like a Tesla can scan the environment in real time and a Sony camera can track objects in real time, it should be possible for an iPhone to do the same thing, particularly with its high-end processor. So in theory, it should be no significant technical feat for an iPhone camera to be able to observe its environment quietly and make its observations without even generating any network traffic. This is doable, just like in a Tesla, because the AI is on the phone itself, not in the cloud like Amazon Recognition. So think about that carefully. Think about the iPhone independently judging its environment and reporting anomalies it is programmed to report to Apple. This is the next progression, and technically speaking, it would already be able to do this. Apple's stated approach is that they will only scan actual saved photos and photos intended for iCloud. However, this feels so fake that I don't know what to say. If the intent is to catch those who store illegal images on their phones, then announcing that intent will basically practically eliminate the chance of finding such criminals. The criminals will just dump their iPhones. In the meantime, the technology will remain on the phone, not catching anyone, but with the capability to be retargeted with a different objective. Reminds me of the Patriot Act and the FISA courts. They never get undone. And the stated iCloud limitation is so obvious. They can already scan iCloud today since iCloud is not end-to-end encrypted. This limitation is PR related. They already know who has illegal images in iCloud, and announcing this further like this gives criminal users warning to delete such images. So I don't know what the point is. As will be expected, who will get caught? They already know the criminals, but give them a chance to get away with this announcement. Thus, this further cements my theory that there is more to this and additional long-term targets, probably secret targets. Let me move on to the second part of this technology, which is the AI instruction to the remote device. In the case of Amazon, a custom encrypted network connection using Amazon Sidewalk already exists, so they can pass instructions to a Ring device at will. Google has a similar architecture called Google Thread. This is the Amazon Sidewalk counterpart, which allows Google to send and receive messages to IoT devices without an internet. I haven't heard if Google is putting image recognition AI at the device level like Apple. They are, of course, doing it in the cloud and are scanning your Google Photos, email, and Google document files. So maybe this is coming, but possibly not here yet. And as I mentioned earlier, the Amazon Recognition AI is a cloud service and not embedded in the device, at least for now. So devices with image scanning AI at the device level, like an iPhone or even a Tesla, has an interesting potential. Apple, though, is doing something interesting. The image scanning AI needs some parameters that identify a match or a target. The iPhone will code the result of any analysis of any image it sees into some context of the image, similar to what Amazon Recognition does in its analysis. But this will be done directly on the phone. And as programmed by Apple, it will convert that image finding into a cryptographic hash. This will render that observation non-discoverable by a third party. It is not possible to derive the source data once you turn it into a hash. On Apple's end, their target images will also be analyzed for context and turned into a cryptographic hash. Then the iPhone will be fed a list of hashes. If any iPhone image scan result hash matches the hashes provided to it by Apple HQ, then it would confirm that the target is a match, and HQ can then be alerted. Interesting how the use of hashes actually make everything secret. No one in the middle would be able to interpret what the hashes mean. The hash values would correlate to an observation target, but no outside party would be able to confirm that. Again, to make it clear, in order for this to work as I expect, the hashes have to be based on an image context, just like the observations of Amazon Recognition, and not a hash of the image itself. The process that most people think Apple will do is to create a hash of the collection of banned images that they have access to, and then use that hash to compare against the hash of images that are found by the iPhone. At face value, this explanation is plenty flawed. Hashing, like for example using algorithms like SHA-256 or SHA-512, guarantees that two separate sets of data will be identical if they have the same hash value. So because of this Apple explanation, everyone then presumed that you would simply compare photo images byte by byte and then make sure they match. This, of course, would lead to failure, since any modification of the image in any way, like resizing, rotation, image adjustments, like contrast, brightness, color grading, and so on, would change the hash. For a hash match to work, the files have to be identical. This alone is a difficult target, since merely uploading an image to a platform and then downloading it thereafter changes the resolution of the image and the metadata called EXIF or EXIF. It also wouldn't be able to recognize a similar photo, since any difference in the photo will result in a different hash. If a criminal in possession of a banned image simply adds a dot in the corner of a picture, that alone will change the hash. So the idea that hashing images would cause someone to catch a criminal possessing banned images is ludicrous. The chances of a match would be extremely small. And you couldn't catch anyone creating a new illegal photo. Thus, For this reason, I postulated that they cannot possibly be hashing the bytes of a photo file. Rather, they must be hashing the analysis of the image, which is a lot smaller for one. By using the discovered parameters of the image scan instead of the bit-by-bit image itself, then the scan result would be impervious to image modification. This then makes sense as a better way to create a signature that can be hashed, and the name neural hash gives us a hint already since it implies an AI pre-processing before it is hashed. Aside from the characteristics of faces and image itself, as you saw in Amazon recognition example, the ability to recognize a context like a suggestive pose or revealing clothing, clearly more subjective elements. If a particular photo is being identified, then the attire and description. So my premise is that the neural hash is not a photo hash, but the hash of the image analysis of the AI, including context based on an image analysis performed similar to Amazon recognition. Therefore, if that is the case, then Apple is able to provide a target to scan simply by passing similar criteria. A contextual observation plus some more specific identifiers that an AI can record, like facial measurements for each face in an image, if the target is a face rather than a situation or event. And of course, it could target either. This targeting can possibly be quite sophisticated. Give the phone a set of criteria to observe, and then the observation can be done when the photo is saved to file. Or in theory, nothing is stopping it from analyzing the image seen by the camera even when it is not taking a photo. And that's pretty scary. So basically, an elite group of Apple employees can decide what images iPhones will look for in their environment, and no one will be able to check to see if they really are looking for criminals or if they are instead looking for a Jason Bourne. Now, the justification is to catch criminals storing illegal photos. But with the advance warnings given, the supposed iCloud limitation, and the flawed hash explanation, clearly this isn't really intended to catch any criminal. They can already catch those criminals today without a further change, just by scanning iCloud. Instead of doing that, they set up an infrastructure for quiet surveillance that can be really controlled by very few, and are putting a distributed AI architecture. So what is the long-term goal of this kind of infrastructure? Obviously, for better surveillance. I'm on the platform Odyssey.com, and I'm now one of the top creators on there. Just for insurance, in case I'd get deplatformed, please follow me there using the link in the description. If you found yourself enjoying my videos, I hope you support the cause by hitting the subscribe button and the notification bell. That will help us grow the message. Thank you for watching, and see you next time.